Hello everyone, welcome to UC Irvine Master of Engineering Capstone Project Showcase. My name is Max. I'm going to be your guide to walk you through our project. This thing in my hand is a cervical plate that goes to the front of your cervical bone. And our project is all about this little thing in my hand. The name of our project is called Textured Plate Design for Improved Reliability. Hoag Orthopedics and Surgalign are two of our sponsors. Here is our team roster. Cordelia Miracle is our team leader. She and Patrick are majoring in biomedical engineering. Myself, Max. Jiayu and I are both majoring in mechanical engineering. Our sponsors include Jeremy from Surgalign and Dr. Gardner and Teddy from Hoag Orthopedics. The initial idea of this project comes from Hoag residency research, wanting to look for better friction for plates. Previous efforts were made on humerus bone plates, and we were able to use similar approaches on our project to test cervical plates. By decreasing failure rates, less patients will need to undergo revision surgery. So time will be saved, money will be saved, and it will bring a faster healing rate to patients. The purpose of this project is to design and test various surface textures and perform static and dynamic testing in order to understand the best cervical fixture design. The best design will be able to handle strong forces in order to resist failure. Also, the best design will have the most stable performance in testing conditions. All of the texture designs will be compared to smooth plate results. Before testing, we need to design our baseline smooth plate first. After a couple design iterations, we have decided to go with our easiest designs. There are a couple reasons for that. First, we got rid of locking mechanism, because locking mechanism does not affect testing result at all. It's only used to locking screws. And we cut down to one level plate because simply test the friction difference between smooth and textured surfaces. And we made it flat because flat plates are standard. Plate will be curved differently with different patients. And with baseline design, we've come up with 3 more texture designs. And these designs are inspired by our daily life. Trap plate and handlebar are both designed to increase friction. Thus, we just applied those 2 designs to our plates. The final 4 designs we decided to go with are smooth plate with trap plate textures, and 2 pyramid plates. One has half of the pyramid density compared to the others. Our assumptions are pyramid texture is optimal to create high surface friction because we have found some papers related to this design. And trap plate will be a good starting point to compare against pyramid because it was the optimal design in the previous humerus project. Here is our testing setup. This one in the video is the static test. Upper block is Symbone and bottom block is polyethylene. And test machine we use is Instron machine. We set the strain rate to 1 millimeter per minute and we test it until breakage occurs. So here are our static testing results. From the table and the diagram, we can see that there's no significant difference between braking force, and the force aggregation process is pretty similar too. So this has indicated that different texture types doesn't have significant impact on increasing fixation, which is really different to what we have expected. But we did find some interesting points, which is the failure point are different between fixtures and smooth plates. Smooth plates all break at screw holes, but textured plates broke at top of textures. So we are making a hypothesis that adding textures might have added force concentration that caused premature failure.
For the dynamic testing results, we have a graph showing the maximum compression forces for cervical plates under dynamic loading, blue being for the smooth plate, orange being for the 50% pyramid plate, gray being for the 100% pyramid plate, and yellow being for the tread plate design. The graph on the left is shown in negative forces for compression, and each test was run 3 times with the averages being shown on the rightmost column. In conclusion, the data showed that the smooth plate required on average the most amount of force to cyclically displace the cervical plate. Now this was against our hypothesis, which was that one of the textured plates that actually yield a higher compressive force requirement.
So in conclusion, static tests didn't show a significant difference between each designs, and both static and dynamic tests didn't reflect what we have expected before. But braking positions are different, and this potentially is caused by force concentration textures created. And this needs more supporting data, which brings us to the next steps of this project. We can always add more data points to support our project, and we can make the test constraints more restricted to reduce human error. In this project, we have faced a lot of challenges.